All right, there was a problem on the last quiz that caused trouble for many of you, so I want to take some time to look over it. It talked about a division problem where it described the the dividend, the divisor, and the quotient. And it asked what happens if you change one of these two values, or maybe both values. What happens to the quotient? And those who got it right often gave an example. Let me give you an example. Let's say 800 divided by 20. And some big numbers there. Okay. Well, if we look at the fraction instead of the division problem like this, it's a little easier to see. But if we're using numbers, it should be okay either way. Right? So first situation, the first number gets multiplied by 5. So 800, well first let's do the division. 800 divided by 20, I can cancel a 10. 80 divided by 2, that's 40. All right, if I do long division, 20 times 4 is 80. No remainder, that 4 is in the tens place. My decimal's way over here, so I need to put my 0 as a placeholder. Right, so there's my 40. But what happens if I multiply the numerator by 5? So 5 times 8 is 40. So now I have 4,000 divided by 20. So it's not 800 divided by 20, it's now 4,000 divided by 20. Well, we know from how we solved one-step equations, if I have an equality here, a divided by b is equal to c, if I'm multiplying this left side by 5, in order for it to stay balanced, the right side also has to be multiplied by 5. Right? Otherwise, they wouldn't stay balanced. So the new quotient is 5 times c. The new quotient is 5 times bigger than the old quotient. All right, so in math, when I ask you to compare, that's always like greater than or less than. Which of these is bigger? Which of these is smaller? By how much? Are they bigger or smaller? Right? We don't know if it's 3 bigger or 3 billion bigger. We know it's 5 times bigger. Right? We don't know what the addition difference is, but we know what the multiplication difference is. But the new quotient is 5 times bigger because this quotient is 5 times bigger. And we can see that with the division. So 4,000 divided by 20. Twenty goes into 40 twice with no remainder, but that 2 is in the hundreds place. Right? 40 times 5 is 200. Well, what happens if we make the bottom 5 times bigger? If we make the bottom 5 times bigger, we're multiplying times 5 down here, right? Our denominator is getting 5 times bigger, right? I'm not just dividing by 20, I'm dividing by 20 times 5, all of this. So instead of 800 divided by 20, I have 800 divided by 20 times 5, which is 100. And 800 divided by 100, that's 8. Right? How does 8 compare to 40? It's 5 times smaller. In this case, the new quotient is 5 times smaller than the old quotient. Okay. Now, the third option here is what if I do both? What if I multiply both the numerator and the denominator by 5? Both the dividend and the divisor being multiplied by 5. Well, 5 times 8, that's 4,000. otherwise known as 4,000. 20 times 5, that's 10 tens, that's 100. So 100 goes into 404 times. No remainder. That's in the tens place, so I need my placeholder 0 here. That's the same, right? If I'm getting 5 times bigger and 5 times smaller, I'm right back to where I was before. Those 5's cancel out. In this case, the new quotient is not 5 times bigger or 5 times smaller. Whether we're thinking in terms of measurement size or just any value, the new quotient is the same value as the old quotient if they're both 5 times bigger. So one way to think through these kinds of logic problems is use variables as placeholders, right? That's how we deal with formulas for perimeter or area. We're using variables to indicate certain values. So I hope that was helpful for you. Let me know if you have other questions.